So good evening. It's 6 o'clock, so let's start. So welcome to the Network Management Operation to the NMOP working group. This is our second session today. The session in the morning was dedicated to the documents. This session is specifically dedicated to the hackathon, and it's the opportunity for people who've been developing to show what they've been doing based on the 3 experiments we have in NMOP. Sorry. So even if it's the second meeting, we need to read this note well. That tells that by participating in the IETF, you agree to follow the IETF process and policies. Please read the list of documents. And not very well that we have to treat each other with respect in this working group. And this is what's going to happen. And in case it's not if it's not the case, then there is a procedure for that. By the way, I'm Benoit, and this is Matt for the people who are new in the session. So if you want to participate in the session, you have to log into the data tracker or get the QR code that you see there at the microphone or the entrance. This is the way to join the microphone queue. And that's also the way to participate in the show of hands. So keep audio and video off if not using the on-site version. So the agenda for this meeting. We're going to report on the 3 experiments, which is first the Yang push with Yannick, second one, digital map. This is Sheriff and Henry on 2 different aspects of the map. Then there is the network anomaly lifecycle. And finally, there is one part which is not in the charter, which is about knowledge graph, and Mike will present that. At least the work in the IETF. All right, any agenda bashing for this? Let me see, Yang push. Yeah. So we could be starting with Yang push. Thanks, Yannick.
Thank you. So hi everyone, I'm Yannick Books from Swisscom, and I'd like to share with you the results of our hackathon last weekend, which was validating Yang push publisher implementation for configured subscription. So our goal was especially to validate this implementation in regards with our development plan, so our roadmap of minimal viable products, which is actually the feature set, the contributing or participating operators defined as being their common interest. So once we reach the MVP1, from our perspective, we would be able to deploy this in our environments. We got 3 Yang push publisher implementations and 2 open source Yang push receiver implementations, and we used UDP native dissector for Wireshark. All the results can be found on this GitHub repository. It includes the packet captures that are readable with the dissector I just mentioned. It includes the messages we're just gonna look at in a few seconds, and it includes also the automated test sequences. So first of all, we need to look in the overall where we are. You can see here on the right side the Yang push to Kafka message broker architecture, which has as goal a fully automatable pipeline. This is what we operators are aiming for. And on the left side, you see the list of documents that were the specs actually for these implementations. We're going to see in a sec. So let's start with the Cisco iOS XR, a young push publisher implementation. So for the subscription change notification, we can see the different specs that we had listed before. So thanks to the encoded namespace, you see from which of the drafts the different pieces come. So one important thing for us to have the end-to-end preservation of metadata is the system name and the sequence number from the sequencing draft in order not to be forced at the collection process to add some metadata. So we'd like to have this coming from the origin. What else can we see? Yeah, I think that's more or less what we see here. So the two started and terminated notification. Then for the push notification, we have the push update and push change update messages here from iOS XR. Yeah, and an important piece as well that was added is this observation timestamping draft, where we see for the periodic notification that this is an accounted value, right? That had been accounted over the interval, and on the other side, for the push change update, we see that it is the point in time is actually the state change, right? And the timestamp is important because it is really at the time this metrics was collected in the system and not the time that it was exported towards our data collection, which is the event time from RFC 5277. Then we have the same was validated for Huawei VRP. You can see also another addition here, the distributed notif draft, which for distributed system adds this message publisher ID. Then priest.
Oh, yeah, sorry.
Okay. Another crucial piece of the whole architecture is the ability to, in an automated fashion and efficiently retrieve the schema tree from the device. And that's what is demonstrated here, the augmented by draft that was implemented in VRP, and that was also part of another hackathon project, which was able to build the whole schema tree there. And then finally, the third publisher implementation was 6Wind VSR. Yeah, just to have another sample here. And maybe you can see here the versioning draft as well that is at the bottom. So supporting multiple Yang model revisions to be referenced in the message. Yes, yeah, that's it for the examples. And then we also verified the transport part, so the UDP notif part, as well as the optional segmentation for the 3 vendor implementations and the 2 open source Yang push receivers, and that the sector is also able to reassemble it. And then in terms of these milestones I just mentioned before, that's the current progress. So we're very confident that in next IETF we can fill this first table. Exactly. So what was achieved is the green marks is what came as an addition into this IETF. And we also have some achievements for the next milestones, which is here. It's the secure and scale milestone, we call it, with the distributed notif draft. And for the third one, which is the optimization part, is our last priority. We have the on-range coverage and the transport capability, so the way to discover the discoverability of the transport, right? And then there was another project also related. So for another transport, the HTTPS notif was done by Maher and his team. So that's a summary of what they achieved. They were mostly on the validation of the transport there. And yeah, you have here all the resources if you're interested in. So that was the team composed by vendors, operators, developers, yes, on-site and remote. And yeah, thanks to all of them for a great job. So that's it for my presentation. It's quicker than thought.
It's refreshing that people clap whenever you got code at the IETF. So I could second that. So any questions, feedback that people have on this? Then thank you. Well done.
Thanks.
Okay, hello everyone, I'm Sharif. So today we're trying to share what we did in the hackathon and the results from last, basically we did some work before, but then this is more sharing what we found and what we did and hopefully the next steps. So this is in general the project info. So what we're aiming to do with the CMAP now. So yeah, well, digital map / CMAP now. And so far we are trying to do, one part of it is trying to map all the layers from down to up using the RFC 345 that we have. So we have so far went through, used some drafts for layer 2, layer 3, and I think last time ISIS as well. So this time we added more things in this hackathon. So this time we did start to address a little bit simulation scenario in the context of topology. The other part is we did some discovery labs for new labs basically for Swisscom and Telefonica. And the new part as well is that we try to link to some external information, which is in this hackathon, it's more like in the configuration aspect. And we will see, we will explain this in few slides. So this is in general the labs that we used during this time. So we have down there, the OSPF lab. This is the one that we built, and so this is we had the OSPF lab, but basically we did some mapping as well to map the OSPF plus the underlay layering in topology. And then we have the one in the middle is emulated one, and it's same one from Telefonica, and the one on the right, we recently did discover this in the hackathon as well from Swisscom. Yeah, so this is I'll take this example, and then that's the one we will take for more details in the scenario in the coming slides. And this one, you will see this is the real network and this is emulated network. And the scope here is not to say how did we emulate it, but I will describe it in the next slide. But let's keep this in mind that we have a real network, we have an emulated network. And then to build the emulated network, let's say we use the topology, we use the configuration, and maybe some hardware aspects as well. So this is just describing the scenario that I'll be using this presentation. So, I don't know if it's you can see this, but so the scenario is we have a real network on the left, and basically want to do some change. And then what we do is we're trying to do this change and then see the effect of this change on the topology. So the first one on the left, basically the state 1 or state 0, where you have the real network. And then 2 is where there's an action made on the network. And you can see, you know, this is a simple action, but it's basically shutting a layer 2 link. The one on the right basically is the result at the end. So state 2 and state 3 are more in the emulated network. So you have the real network, and then you have the emulated network in the middle, the state 2 and state 3. So state 3 shows that we shut layer 2 link, but on the map, the end result that we are going to see, that we see a layer 2 change as well. The other part that we will see in this scenario as well is how do we find the link, or how do we go to the configuration of this interface, for example. So this is where we try to map to the external sources. This is the same thing that I was discussing, but this is going through more the steps basically, that here we're shutting a link, and then step 3 is where we see the effect of layer 2 change on the upper layer, on the overlay protocol in this case. So this is a little bit, I'll try to put this in one slide so that it's kind of obvious. But so the thing is, this is before the change. So imagine, you know, remember the previous slide. So this is the one on the C in the one. This is digital map or digital map API query that we can only see the links for this area. So this is, I don't want to put all the response, but basically this is for the sake of this demo or sake of this slides, basically scenario. I'm only showing the links that are part of this area, and you'll see they are up in one. And then 2 is where will come in more details later, but basically in 2, that's where you say, you know, show me the reference, or basically the external link, that I can get more information about this link. So you're giving the link ID or the topology information, and then you're retrieving some external things, external, you know, fields that help you to find where is the actual the interface data, basically. So in 3, you're able to get this response. You're able to do another query, and then in this case, it's let's say it's a REST conf query. You're able to get this information from the web. Let's say this can be a device, can be a controller. 4 is this where you see, you know, both links are up. This is the interface. You see it's up. This is after a change. So it's more or less the same steps, but the thing is you see a change in the topology. So you see one link is missing, and then you are able to trace this and find that the interface is down, basically, is shut down. So in the first one, you see missing layer 2, missing layer 3 neighbors. Down there, you see this is the link that I shut, basically. So the takeaway of this one is we're able to see the change in the topology. We're able to see a change of underlaying, or how the underlying change can affect the upper stream, up overlay one. And the other part is how to find external reference as well. So yeah, that's the same slide. This is before and after. What you see here is basically, this is a Neo4j visualized output. So we store the relations, the node IDs, everything in Neo4j, just to be able to easily visualize this. So this is the same query before and after a change. Now I'll focus a little bit on the external part. How do we do the external reference in this case? And there are many things, but we're trying to focus on this time is, as a first use case, we're just picking the configuration. But our hope is we are doing a generic one that works for any one of these aspects, basically. So this is kind of the same response that you saw in a couple of slides before. This is more describing that we try to put some grouping that we basically, how do we map the topology IDs to, in this case, some XPath responses that we will need to have to see in the response to be able to do another get call to see the actual data itself. So on the one below, you see we have some group IDs mapping to some XPath, and then in the top you see that for a specific instance you try to put some you link this to some groups, which is down there. So you're kind of trying to put some rules and then refer to these rules with the instance IDs. So I know there are this is our first attempt, so there are so many pros and cons around this, but we're trying to just maybe initially do a first POC and see how the whole workflow would work, and try to collect feedback from people to see if there are any what do you think about this approach. So this is more details on the lab, OSPF lab that we did. So this is what you see in the top is the OSPF layer. What you see in the down is subset of the physical or layer 2 part. So just to keep it simple, now you see the 3 areas, the mapping of them. What you see in the OSPF here a little bit that one of the things that we try to map here or have some problems in the mapping is where we have basically connecting areas or connecting networks together. So this is where we have some replicating of some node IDs in different areas and then using the supporting to connect these 2 areas. Now we are looking, thinking about what we can do in this case, and basically looking to see we can interconnect networks in a better way, basically.
So Sheriff, what you mentioned there is based on the 8345 right now?
This is based on the 8345 right now because you cannot have links between networks. So so here basically it's same node ID, but in different network domain. Yeah. This is the last lab that we got, and thanks for Swisscom. So we got the access to the lab, and then we did some discovery, basically. So we started discovering the layer 2 ISS in this case, and we hope we are going to add more layers. So thanks to Swisscom folks. And we did discover one bug that we reported as well. This is kind of, I'm going through the labs that we did. So the previous one is OSPF. This is the ISS emulated one. So we built this emulated network, virtual network, basically trying to emulate the Telefonica lab to be able to do some of the scenarios of changing and then discovering before the change and after the change. And you see, I didn't put all the supporting layers, but on the right there you see the ISS with the layer 2 supporting in this case. So this is in summary what we achieved this time. So basically what I was describing, basically we discovered some labs, we did some kind of initial thoughts about how for example, taking what if scenario and putting some of the external link into other configuration just to put this in the right context or in a useful context in this case. And we did some a little bit deep dive on the how to connect to external domains, but I think this is the part that we need to, this is one of the things that we need to extensively work on for the next hackathon. And this is one of the other parts that we're going to work on for the next IETF. So we are still going to add more layers on top of ISS. So in this case, BGP SRv6, and I think we can put services on top of SRv6 as well. The other part is to connect to the services, basically. So extending a little bit the configuration to other parts as well. And hopefully we get basically more labs, and when we discover the more labs that we have, the more different scenarios that we can cover, and just to be able to test that APIs that we have, to see what are the missing things that, let's say, from RFC trivial 5, and then we keep enhancing this. And thanks for the team members. Thank you. And that's it.
Thank you, Chief. Just one question for clarification on the, you've mentioned many times the discovery part, and actually this brought me to the comment made by Rob this morning about how we feed, I would say, the digital itself and so on. So is this, can you just elaborate a little bit on how you are doing that part?
Yeah, of course. Yeah, I think I did one because it's quite big a little bit. So I think I have, if anyone wants to have more details, there is, I think, a video in the last NMOP for more details, and there are more detailed slides. But in general, what we do is we look at the different Yang files that we have for every topology. We use this internally in the tool that we are doing, and then we are doing some mapping. So you read basically the configuration, you read some of the Yang modules from all the devices from different layers, and then you take this data and map it, use the Yang files that we have as a modeling to map different, basically getting data from, let's say, LDB, from config, from IETF, ISS, from different modules, and use them in every layer to build this, let's say, innocence, data innocence in every layer on top, from down to top. But then the other part is as well, we look at the supporting so that we make sure we have the right data in every layer that we are able to do supporting from, let's say, from overlay to underlay. So we use the modeling, and then we use some mapping logic that reads, or basically we don't read the configuration directly, we download the configuration, and then offline we're able to do some, we're able to map the configuration to topology entities in this case.
Yeah, that makes sense. Any question to
Samir?
I'm too short. It's not fair.
I think you can.
No, you have to jump.
Just continuing with the question made by Matt, can you elaborate in the network requirements, which are the protocols that you are reading, or you are reading only the configuration? And a second question is it possible to directly integrate with another controller, not with the network, but a controller that is exposing the IETF topology?
To read the config, or basically to build the topology, we don't need direct access to the devices, but at some point you need the data coming from the devices. So if you have let's say if you have a daily backup that you're doing to collect all of this configuration, then you can build the topology out of this configuration. Now, like, let's say running configuration may not be enough, but basically you need some semantics around this. You need a little bit of a structured output. So what we use is Yang, the responses of some of the Yang modules that we need. So you don't need devices, but you need, if the data is stored in the controller in different place, it's easier to do. That's what we do at some point, that we don't need direct access to devices. We collect this. So we have a step like collection. And then once we collect, basically it's offline. We can do anything on this part. Basically, that's how we do it as well. The what if, so we don't change anything on the device, but we have the data, and then we are able to change and then revert back the change. Thank you.
Is this mic on?
No.
So it seems the mic is not on. Is there like an API for that?
You,
I'll shout.
Yeah, but
You can use.
You can use this.
Yep, as you want.
So hi, I'm Olga Havel from Huawei. So I just wanted to emphasize that our focus here was really on the northbound APIs, you know, so we are sharing the POC, the hackathon code, but really, you know, and we have examples how we are retrieving from the network, but it doesn't mean it's the best way to retrieve it from the network, you know, so we are looking at configuration files, but there are other options, and, you know, we can look at BGPLS, etc., which we may do in the next iteration. But the focus here is really on the northbound interface, what are the gaps, and comparison of the RSA 345 and the gaps that we identified and how it compares. So really it's about northbound interface from controller, the SIMAP interface, and how you collect it. It will probably be dependent on the controller, how they want to do it, in which approach, but it should be generic enough that you can collect either from devices, any type of protocol, or any controller.
Thank you. Thank you, Sharif. We can. Okay. Yeah.
Thank you.
I'm too short. Hi, everyone. I'm Henry Yu. I'm from Huawei. This presentation is about T topology graphical display hackathon. It's good that we use a T topology instead of a digital map, so I don't have to change all the places. All right. So, okay. Which one is the next one? Oh, sorry. Do you know which one is next? But
number 2.
Yeah. Oh, okay, thank you. The essence of the hackathon is that we developed a young toolkit that can help us to graphically display the T topology JSON instance. And this young toolkit, though, is not limited to just T topology young model. It's actually a generic toolkit that can help with other young models as well. Okay. Oh, backward. Okay. So this is a brief description of the young toolkit. So the essence is at the bottom, which is actually a young simulator. It contains a young data store, which can accept a JSON instance of derived from a young model. And for example, a T topology JSON instance. And then we developed a RESTconf server, which retrieves the data from the young data store. And then also we developed a GUI client, which can graphically display the T topology instance retrieved from the young RESTconf server. All right. The demo contains 3 steps. The first step is to inject the T topology JSON, which is an instance of T topology. And this T topology JSON is derived from a T topology profile. A profile is mainly just a subset of a T topology model. So in this profile, we just selectively collect the relevant attributes for the hackathon. These attributes are explained in the next demo step. The first aspect of the T topology we like to introduce is the T links contains both the bidirectional and the unidirectional link. So the GUI is able to display a bidirectional link by showing both arrows. Which is quite handy for us to visualize the T topology rather than just read and find the bidirectional versus unidirectional in the JSON string. And also another aspect is the multi-layer of the topology. So in this example that we did in the hackathon is show 2 layers of topology. The top layer is OTN topology, and the underlay topology is WDM. And we show 2 topology is for a reason. The reason is to use it to demonstrate it's okay. It's just to demonstrate the hierarchy of the links. By hierarchy, we mean that a link on the overlay topology can be related to a path which is ordered links in the underlay topology. And in the T topology, a key aspect is that it defines one primary path corresponding to the link in the overlay topology, and a multiple backup links that can be defined as a backup path to protect the link of the overlay in the overlay topology. Actually, the third step of the demo is to show the Swagger interface, Swagger client of interfacing with the RESTconf server. For users who are not familiar with RESTconf interfaces or not familiar with the YANG model such as T topology, this tool can help to help people to use the APIs. Commonly used APIs can be defined in the Swagger for people to use. So this is just try to illustrate this idea. And in this demo, we because it's just illustrate the idea, we only develop 3 Swagger interfaces. The first one is retrieve the topology, which is the same topology that displayed by the GUI. And the other 2 is to create a link and delete a link. Yeah, I cannot remember the order of. Oh, okay. So backward. That's why. Thank you. Yeah. Yeah. So the last page is I updated it, which is different from the conclusion that I presented in the hackathon, because that conclusion was all related to how to improve the YANG toolkit. But I list a few conclusions here, which is more relevant to this session. So in summary, we demonstrated a bidirectional link that's supported by the base model 8345, and we found that to visualize in the GUI is a quite a practical way to show the difference between bidirectional and unidirectional. And also we show how to navigate between multiple layers of a topology. We also showed the underlay path in the underlay topology that can be related to the overlay link. And also another point, the second point is that the concept of profile. So basically, a model profile is a subset of the original model or the attributes, and we found it's a practical way of simplifying the complex models such as the T topology for applications such as I still call it digital map, but CMap, which only need a subset of the T topology. But the future work, of course, is that this profile is still idea, it's not a standard, right? But a standardized way of specifying what is a profile is beneficial in our opinion, right? And it can be further studied. All right, thank you for your attention. No questions are allowed. Sorry.
Okay. She's used to the stage.
Hello? Can you hear me? Okay. Sorry, I have to turn around because it's not working. I just wanted to remind everybody how we started with 2 hackathons, because there was a kind of side meeting at the IETF 120. Then we had a interim meeting, and we have 2 proposals, whether to use RFC 345 and some BIS or some augmentation with gaps, or whether to use TE model as a core base model for multi-domain, including, data center and everything. So from my side, and Italo, you may add later, the TE is a great model for traffic engineering, but it is very, very complex model. So for other use cases that are not traffic engineering, it may be too complex to express the interface definition to the application developers. So the guys are proposing there is agreement about complexity of that model, I think, but you are proposing to come up with some profile approach, and you use it. My comment would be that the profiles are not currently in the Young, and it's not only about profiles, it's about adding them to capabilities, adding versioning, So it's a very, very big exercise that probably, I don't know, should go to NetMod or somewhere. So from that perspective, I just wanted to say that from this kind of approach, you assume profiles are mandatory, is it?
If you can,
So, sorry. Yeah. So my opinion is this. I mean, when T topology first started to develop, I mean, I'm not the original author, but I sort of know the history. It started as simple as well, but then later on, we found more and more need to add more attributes, and it becomes more and more complex. So to reduce the complexity, right, for other use cases, I mean, that's why we come up with the idea of being using a profile. I mean, for a CMAP, we like to start as simple as well, but it could go through the same path of adding more and more attributes. It could be, right. So yeah, so that's the concern.
Yeah, just one additional comment. One of the goals of this, I would say, hackathons is actually to assess whether the level of complexity and go beyond claiming that it's too complex, we cannot do it, and etc. And the hope I would like personally to see in this work is to show some evidence whether it is complex or not. Playing with profiles, is it worth usable, and so. So we started. So it's really thank you for coming to this working group to do this work. So please continue. And the next time, what would be really good to have is to sync between the 2 teams in terms of the objectives and also the goals of the experiment, so that we can have the same reference there, so that to do some comparisons, right. And we will take the appropriate decisions and conclusions when it comes. So go beyond just claiming. Right. Yeah. So next, Italo, I don't know if you are.
Yes, I want just to comment that we are not living on a silos-based network. T and non-T applications are going to coexist in the same network, and having different solutions for the different problem will be very complex to accommodate and to achieve multi-vendor interoperability, because people can start implementing solutions which are non-T, then they need to add T, and what do we do? Or they can start from T and then they need to add non-T, then what they will do? Which solution is going to do? Are they going to do augmentation to T for supporting non-T, or they are going to do augmentation for the non-T topologies to support T? So it's going to be, in the long term, and I agree with Harry, new requirements will come up. It's always the case. And new stuff will be added, and at the end it will be exactly the same, because the complexity is the complexity of the problem. You have a lot of information to report if you want to know exactly the state of your network, and you have a lot of information to report if you want to navigate between across layers. And this was a key requirement, because for TE and optical transport network, multi-layer is a non-starter. If you don't support multi-layer, you cannot manage any transport network. So that was
I think your point is clear, Italo, if you can move to the next one.
And I agree, it should be NetMod, and it will be beneficial if you start in NetMod this work to be applicable to everywhere. Why not only T topology? Every model has this problem, in my opinion. So
thank you. Anyone?
Yeah, just a quick comments. First one is to Olga. You're talking about like whether a profile is mandatory or not. It is actually not. I mean, the reason why we choose use profile is because the people don't want to implement the entire T topology, right? So using a profile could minimize the effort, but it's not mandatory. You can still make use of it. Right, for CMAP, right? The other thing is the definition of the profiles. Definitely, it's a generic generic method that can be done in NetMod. And also the last point I'd like to say is the main reason for this hackathon is to show like we already have definitions in T topology, and that for example a few of the gaps identified for CMAP, the bidirectional link, as well as the underlay path that has, we show through this demo that it can be already interpreted by using the T topology.
Thank you. Julien?
Julien Maric. Well, I think I've been hearing this complexity stuff about T since the old days of GPLS. But as soon as we move to circuit-based, we do T, whether we name it like this or not. So I don't think the complexity is enough to get rid of what is there. And as an implementer, because I have an implementation of optical implement extension of the T topology model based on the base topology, I don't think it's that complex. So of course there are more material in the T extensions, but they are absolutely required as soon as we move to circuit-based technology like WDM or OTN or whatever. So I don't think we should just use the complexity as an argument to compare or to select something, because it's required there and manageable.
I've got no skin in this game. I'd just like to say that in the presentations, I have to say, in the first one of these presentations where they're sort of modeling the map and things, it was sort of confusing to see the bidirectional links on that, because it was not sort of intuitive as to why you'd have a pair of links connected to everything together. So I don't know whether that can be hidden and not shown, and that's a valid solution, whether that breaks, but certainly it felt like that was not like a normal way of I sort of view a network. So in my argument, seeing some way of potentially optimizing that would be nice. I'm not saying take this stuff out, but I think there's something that needs to be fixed here in some way.
Hi, Oscar González, Telefónica. Just I want to make clear that one of the key questions here is choosing the base model, because when we go to and we put optical here, we will need to go to T. You will, no matter what you will do, you will end up in the same place that we went. Okay, so here I'm pretty sure that we will end up in T. But do we need that for the core model? Maybe not. So this is why please stick the discussion T non-T to the base core model, because then we will need to augment from there, and when we augment from there, I'm pretty sure that T topology will be useful.
Just be short, please. Olga.
I'll be very short. I'll just reply to complexity. And my proof of complexity was presented last time, and it's not complexity for traffic engineering, but for the core SideMap model. And the complexity is number of lines in the YANG file. So we can, we had that comparison during the meetings. Let's say 30 versus a few thousand, sorry, maybe not, maybe many hundreds. So that was the only comment. But of course, it's needed for T. It will be used for T. It's just about the core model for all use cases.
C'est bon, passe à la suivante.
Vincenzo.
Yes.
Yeah, if you can make it in 5 minutes.
Okay.
That's what you promised. So
No, it was fun. But anyway, good afternoon, everyone. Take this. So Antagonist is a proof of concept. It's an open source project, which is our vehicle to validate these two drafts, which have been discussed this morning, and I will try to avoid repetition as much as I can. What's up here? Thanks. So what is, Antagonist is a label store. What is a label store? It's basically a domain-specific database, which a little bit of tooling around, which help network operators and which help actually detectors, validators, and refiners to talk the same language for different stages of the life cycle and exchange data between them in a way that this can help detection systems to become better and better over time. That's what it is. It's a Python project, so it's written in Python, and this is the stage where we started from since the last hackathon. So we have been implementing a bunch of components already. This is the overall architecture. We have a database, which is PostgreSQL. We have the main component, which is the Antagonist label store over there, which provides a REST API. The REST API is based on the Young models, which are defined in the drafts. And yeah, over time, I think Antagonist is just 1 year now. So his birthday was a couple of days ago, and we have been developing a validation front end on top of the REST API, which actually allows the network expert to tag symptoms on time series kind of view or using Grafana, and the front end also, which helps adding, removing labels from the label store as needed, or refining the concern score and all these kind of aspects which relate to adjust the understanding of the anomaly as we go on in our revision. We've also been implementing the refinement module as a Python notebook, which is the same approach that a data scientist would follow while doing that. And we have been testing these with different detection algorithms. Before the hackathon, before this hackathon, we actually tested with machine learning-based algorithms, and with, I think I have a, yes, and with human labels. So basically, network experts trying to tag the symptoms on the GUI that I was mentioning before. For this iteration of the hackathon, the idea was to validate this also with rule-based anomaly detection, and for that we selected our own internal POC of RFC 9418, which is basically a rule-based anomaly detector. And the scope for this iteration of the hackathon was to make sure that we could test that all these different detectors were actually working with the model, and also to formalize better the connection between metrics and symptom. This actually required an improvement of the Young model. So we did that, this is what was done during the hackathon. We've been reviewing the Young models for the label store REST API, because we realized actually while working on the integration of SANE that the current model couldn't work, so we had to update it. We created a new Young model, which also includes the definition of relevant state. We quickly went through this model in the morning, and we extended the Young main data model by means of augmentation. So now we have the semantic that can be augmented as a plugin into the data model, and that's kind of the intention for the usage of the main model. What did we learn during this iteration? As mentioned, we learned that we actually need to make the data model pluggable, especially from a semantic point of view. So whenever you're defining the symptom and the service, this is very specific for different detectors. So we have to open the model for user to augment it and to allow for different definitions. And these are examples of some of the models that we define actually during the hackathon. So we have the Cosmos Bright Lights example. That's the model that is defined in the metadata draft. But also we have an example of a model for the SANE detector and a model for the machine learning detector, which both augment the lifecycle model. Okay, discussion next points. In terms of next steps, I'll be honest with you guys, but please don't tell anyone. I started already with the first line of the next steps, and I did that during the hackathon by telling ChatGPT, asking ChatGPT to generate a refactored version of the API. I got two things: a good news and a bad news. Good news is actually after a couple of iterations, it was almost perfect. So it means that the draft is written in the proper way, because it could generate a good implementation of that. The bad news is that it opened up the need for, since we're plugging stuff into the data models, it opened up the need to replace the SQL database with probably with a NoSQL database, because now we have to open up the way we store the information as well. So this will require the second step, so the extend the persistency layer to accommodate a little bit of flexibility on the model. There's a few options there. We'll try to see which one is the most appropriate in the next step. And we, as a next step, we also have the integration with the Swisscom Lab, which is what we are planning for the next hackathon, hopefully. So there's a couple of open questions, but I think the main one is, I would say, apart from the refactoring which is needed, and if I get ChatGPT to work for me, I probably can get it done fast enough. The code base is stable, which opens up for cooperation inside the working group. People this morning have said that they are interested in working on these two drafts together. And the best way we can work together on this draft is by having some pilots, some tests, some whatever, working with this open source POC together, maybe providing some labs, maybe testing some detectors. So yeah. So that would be fantastic. If anyone is interested in cooperating on this, that's the best way we can work together.
Please, if you can just wrap up, because if we want to, okay, that's great.
Thank you.
Thank you.
Hello. Hello. Backwards, forwards. There we go. Hi, everybody. Everybody still awake? Let's go. Yang to RDF. What's RDF? Well, a semantic triple. RDF triple are simply a triple. And it's a way of representing a graph in the form of a triple. You have subject, predicate, and object. RDF is a W3C standard. It's been around forever, where standards are concerned, 2014. You see here the semantic web stack. This is the basis of what we're doing, and I'll get to why in a bit. So what did we do? We created a Yang to RDF transformer. We did this in a clever way in order to be able to do it very quickly. We leveraged a language server protocol for Yang. So it was written in Xtext. So we had the full grammar support straight out of the box. So we had a parser for free. We translated that into Eclipse Modeling Framework. Eclipse Modeling Framework already has a serializer for RDF. That popped it out the other end. Okay, that looked cool, but it's still not compiled Yang, which is what we want. So resolving augments, deviations, et cetera, So we have this normalization layer that we put it through and spit out some RDF at the end. There were some issues with that though, because the serializer by EMF would use the internal IDs, which were generated, and they weren't deterministic, which is very important for RDF. You want to be able to deterministically use the IRI in order to decide what something is. So we have an extra step that converts the non-deterministic IRIs into deterministic IRIs. And this is what it looks like. So we converted an NE40 model as an example. This is what it looks like. You can see here, each one of those arrows is a predicate, subject and value. So this is what a module looks like. This is what a module with its list and containers looks like. And this is what a module with list, containers, and leaves looks like. So obviously it's a massive graph with 277,000 triples. So what's done, what's left to do? So we obviously, as I said, because we use Xtext, we have full grammar support. So we got everything in the model. We support all of the features, so we do full structural features, so augment, grouping, extension, deviation, fully resolved. We partial translation of the auto-generated IRIs. You can see there, we've done the main ones, container leaf list, etc., the ones you would probably use most. But we would obviously want to make that complete. Code is there, it's open source. Please check it out. Please play with it. Please make it better if you can. We plan to try and make it better. Finally, just to mention my draft, or our draft, because a lot of people in this room are on that draft as well. This is why we want to do it. There was a lot of comments when we did our draft about RDF and Yang being one of like the main areas that we could kind of, I don't know, would be maybe one of the barriers. And here we showed how easy it is, or not. Thanks, Nacho.
Nacho from Telefonica. Thank you, Mike, for the presentation. I'm curious, have you considered using Ying for the transformation?
We did, and we saw your candle. The one thing I will say about what we did, the order which we did, it's very, very fast. So our parser from XText to EMF is incredibly quick. All of our structural changes then are done using Sparkle. So it's actually really, really fast. Sparkle, not the easiest thing in the world to use, but it is there and it does it. We can translate the full device in maybe 2 or 3 minutes. So it seems to be faster than we did notice. I think the Yin approach that you used was very, very good. It's really cool, especially because you were able to leverage the compiler and all of that sort of stuff, which we had to do via Sparkle. But the translation part using RML was a bit slow, whereas our approach was much faster.
Okay, thank you.
We both are good.
All right. Thank you, Michael. So, yeah. Thank you to all of you for the hackathon project. I've been in the IETF for a long time, and actually this is very refreshing to see all that for all the experiments that we have in NMOP. So thank you very much and enjoy your evening.
Thank you. Merci.